All right, we are finishing up our worksheet 34 continued with our notes. So I just wanted to remind you guys of a couple of terms. A segment bisector cuts a segment in half. So here's my segment, this bisects it. I don't know anything about this, but I know that the segment is cut in two equal parts. An angle bisector does just that. It bisects, it cuts an angle into two equal parts. So we've got a large angle and we have this ray as a bisector coming out. It cuts into two equal parts. Now, if you have a perpendicular line, that means they meet at a 90-degree angle. That's what perpendicular lines mean. More specifically, if you have a perpendicular bisector, there's more things going on. It is going to not only bisect, cut something into two equal parts, it is going to make a 90-degree angle there, okay? And the term equidistance means the point is the same distance from two or more objects. So this midpoint is equidistance from the endpoints. So we went over some examples with that, and then we introduced these ideas with a perpendicular bisector, and it almost looks like it's within a triangle. But what I actually want you guys to understand is it could just look like this, an angle that is bisected with this line coming out. Okay, now, if I have that and I create this triangle effect, we have two congruent triangles by side, angle, side, which means these parts, CPCTC, are congruent. Then, when we have that, we actually have one big isosceles triangle. You see the two congruent sides. So we have this symmetry. We cut this in half. We've got the perpendicular bisector. We've got the 2 points that are equidistant from the center. All right, we can flip-flop it. If I tell you that A and B are equidistant from point X, okay, from that bisector, then we know that we have a midpoint that is creating these two equal cuts and a perpendicular bisector that creates that. Okay, so I know that was really exciting for you. And then the last thing we ended up with was right here. This one looks a little different. Again, we've got an angle bisector. So picture what I have here in red. This cuts through the center of it. And if point C is equidistant from each side of the angle and a perpendicular angle attaching to that segment, then we know that these pieces are 90 degrees, or we know that these are congruent. We know that this angle is bisected. So if I give you a bisector, you know these points are equidistant if they are right angles. You know that this is equidistant away, or if this is true, then you know it's an angle bisector. So it goes back and forth. Okay, so we did some examples. We had a little proof here, and now we're into these practice problems. And I think we started a couple of these, but let's make sure we know them. So given that this is 90 degrees on both sides and these angles are equal, then I know that this D is equidistant away from each side. So if that's 16, that's 16. So that is my answer, the length of AD. All right, now it tells me to find EF here. So let me get into that a little bit better. So again, if my angle is bisected, these are equal, and I have these 90-degree angles, I know that this is equal to this. So we solve it by saying x plus 1 equals 2x minus 1. All right, so go ahead. I'm going to subtract the x, and I get 1 equals x minus 1, and I'm going to add 1. So I get x equals 2. X equals 2. Now, that's not what they wanted, though. They wanted the length of EF, which is right here. So it would be 2 plus 1, and the length of EF is 3 units. All right, so not too bad. All right, JM, well, that's a little bit different. Now they're telling us that these are equal distance. This is 90 degrees. If that's true, if these are equal distance and this is 90 degrees, then these angles are equal. And that also means that these sides are equal. So JM is 12 units. So not a lot of math involved, but knowing my properties. All right, QR. Well, this is the same idea. These points are equidistant from S. We've got our 90 degrees, so that means that these sides are also congruent. So to find QR, I need to find X. So I am setting these equal, okay, because it is appropriate to, and then we're going to solve. subtract 3x, and I have 2x equals 8. Divide out by 2, x is 4. Now that's x. So to find QR, it'd be 3 times 4 plus 8. Well, I'm getting 12 plus 8, so I'm going to say that it's 20. So 20 units. Whoops. There we go. All right. Ready for the back? All right, go ahead and flip it over. See what you think. What are the properties of this problem? So again, we have this point B and A are equal distance from D. You've got your 90 degrees. So that means that these segments are equal. So I'm going to take x plus 5, set it equal to 15, subtract 5 from both sides, x is 10. And that's all they asked me to find was the value of x. So I'm done there. However, I could plug it back in. Okay, now they changed it back. You've got now an angle bisector, okay, because your angles are congruent. But see how these are both 90 degrees? That's important. We're going to be talking about altitude probably tomorrow. And the altitude is the distance away from something, but it has to make a 90 degree. So perpendicular bisector, split in half, 90 degrees. That means that these sides are equal. So x is 6. That's it. I didn't have to do any math. That's the length of x. Okay. Equal distance from G, 90 degree angles. That means that these guys are equal. So let's solve that. 3x equals x plus 4. Subtract x from both sides. 2x equals 4. So x is 2. Okay, so now we have a problem about a truss, which is that top of the roof when they frame out a house or a building. Okay, no, x is 2. Sorry. In case you missed that. So in this truss, we have that, and there's a lot going on, but let's focus on this angle, okay? This is what you're focusing on. So we've got this angle, and then you've got this piece in the middle. So let's talk about that. It says that AB right here bisects angle CAD. Bisects C, it should be AB bisects, well, I guess they're telling us it bisects this angle, but CAD. And it says in that ACB, 90 degrees, and ADB, I can't talk, are 90 degrees. So that's a little different. I was thinking it was going to be in here. So these angles are equal. These are both 90 degrees. It says, what can you say about BC and BD? Well, these are going to be equal distance away. That means that these are also congruent, okay? So BC, segment BC is congruent to segment BD. All right, so why are these congruent? Well, this would be our angle bisector theorem. By the angle bisector theorem. I just abbreviated theorem. You can write it out. All right, so let's go ahead and try these last couple. It's about the angle measure. So the segments are congruent by the angle bisector theorem. Okay, now we're trying to find angle measures. So it says that we have this, okay, equal distance, 90 degrees, angle bisector. Okay, well, then JKM right here is also 38 degrees. Now make sure you're paying attention if they want the full angle or just a part of it. Now, they have equal angles, 90 degrees. That means these are equal distance, so SV is also 18 units. So we're getting the same idea each time. We've all these congruent parts. So guys, if you would just go back to your triangles, this is side, angle, side. We didn't even need to know the angle bisector. Side, angle, side. If this is 14, this also has to be 14 because of that CPCTC. So I'm writing down side, angle, side. I have two little congruent triangles, so all the parts must be congruent. So HG is also 14 units. Okay, down here. Angle bisector, these are 90 degrees, so they are equal distance away. So x equals 2x minus 3. Okay, so I'm going to subtract the 2x. I want x on one side. I get negative x equals negative 3. I want to divide out that negative 1. So x is positive 3. Now that's x. So they said find the length of LK, which is 3. It should work in both. 2 times 3 is 6, minus 3, we also get 3. All right, PQ. Here we go. PQ is what we want. Well, these are equal distance. We've got our 90 degrees, so that I know that x plus 2 equals 2x minus 1. I'm going to move the x over here, so I get 2 equals x minus 1. Add 1, so x is 3. Okay, now, they said find PQ, so that would be 3 plus 2, so PQ is 5 units. All right, last one on this worksheet. Find AD and BC. Okay, so AD, oh, I can do that. Well, equal distance, this is also 12, right? AD is 12 units, so I'm going to put that under there. And then I need to find BC. Well, these are also equal distance from B, okay? So that means that 3x plus 1 equals 2x plus 6. Okay, so I'm going to subtract the 2x from both sides. That gives me x plus 1 equals 6, minus 1, x is 5. Now that's x. They wanted BC right here, so that's 2 times 5 plus 6. That is 16 units. And there you go.